I hope what you're getting a sense of is there is good naming and there's bad naming. And believe me, I see types of things like this all the time. This looks, I apologize for the speckled character of this. Pete's aside, dappled things are not always beautiful. Here we have some code, which actually does the same stuff as this bottom one, but we have a stark difference in terms of the naming. This is from Code Complete by McConnell, which is a great book on the subject. I recommend people. I have lots of others I would recommend as well. But here we have, up at the top, the same code that does the same function as the bottom, but we have cryptic names up here on the top, and names that are more transparent down the bottom. So here, for example, we see at the bottom that we update a balance with having deducted the last payment from that balance. Up here, the nature of what's being dealt with, the meaning of what XX is and how it relates to X is totally obscure. I'm sorry to say, but there's a lot of students who end up using names closer to the top than to the bottom, in my experience. See a lot of programs with A and C and B and Z and foo, where they could have used names just like the bottom. Monthly total, for example, here equals new purchases plus sales tax. These are transparent names, and they're a joy to work with compared to working with this. Because you end up wasting a huge amount of time trying to figure out what is meant by these quantities, whereas here it more or less tells you what's meant. And so you can simplify your task. You can divide and conquer, simplify your life in dealing with this code. And believe me, if you wrote this code a year ago and you come back to it a year later, the top code, you're going to be confused as well. Also from Code Complete, here we have sort of good names and some names that really need improvement. So, lines per page, current date. You'll notice the use of anyone know what this sort of convention is called, where we have sort of a lot of lowercase, but we have punctuated uppercase letters? It's called camel case. So here we have a set of variables written in camel case being compared with a set of variables written typically here in all lowercase, and the camel case variables used with capital letters, they indicate a clear division between the words, and often a given name will incorporate separate components, so lines per page. It maybe doesn't give you all the information about, what sort of page this is an A4, letter side, or legal, or what have you, but it gives some understanding of this. Velocity in miles per hour, train velocity. Ladies and gentlemen, some years ago, I think it was perhaps 10 or so years ago now, there was a quite high-profile mission launched by the United States to Mars to investigate that planet. And there was a component of this that was supposed to serve as a satellite around Mars, where it would deploy and then it would actually allow itself to descend to the surface with parachutes. And there was a mistake made in the code because it mixed together quantities computed in imperial units with quantities computed in SI units, System International, in other words, metric system. If the variables had clearly indicated the nature of the units being used and the functionings, literally hundreds of millions of dollars could have been saved. I think it was actually billions of dollars. And instead, that particular mission ended up slamming into the surface of Mars at a much higher speed than they had intended and was destroyed after a 9-month mission to Mars or what have you. And they lost something like hundreds of millions of dollars. I think it may have been billions. So naming variables to include things like units where they're appropriate, when we're measuring things in kilometers per hour, miles per hour, liters per kilometer or miles per gallon for fuel efficiency. These things matter. And they're not small matters. We have a program with several different things, types of information being used. Encoding them in the name can be very, very helpful. By contrast, these names on the right-hand side here will often be quite obscure. You don't know what the velocity is measured in. You may use something called train, which encodes its velocity. You're not even clear that it's a velocity. Maybe it's the length of the train in cars. Maybe it's the weight of the train. Maybe it's the type of grain the train is carrying, what have you. These things are quite obscure. These type of variables on the left, much easier to deal with. Very easy to do these days. Very easy to update using refactoring tools in programs like Eclipse, text editors like Eclipse. So the fact that you have to type these names is often a minor issue compared to what it was 25 years ago. The fact that this is a little bit longer to type than L is no excuse. It will probably spare you so much typing because of bugs you'll be able to avoid to be able to use a clear name. And besides, in many cases, we have autocomplete in today's editor, so we'll automatically fill that in for you. So using names like on the left-hand side is not only required in this course, it will spare yourself a lot of grief. Okay, so general principle names be consistent, give related things names that show the relationship, and be accurate. So for example, here's a name is octal, and someone may use it expecting that. What's the issue with expecting that this is octal? So if you're expecting that this is octal, conceptually it's a function. It's defined as it's commonly defined as a macro in C. If you're expecting this to return whether or not C is an octal, is a legitimate character in an octal representation, what's the issue with what's shown on the right? Is octal a good name for what's given here? If you have an octal character, it has to be between, well, let me ask this. A decimal character has to be between what? 0 and 9. An octal character has to be between 0 and 7. And here we have 8 being allowed. So that name is octal is misleading. And if genuinely this is what you want to compute, you should give it a name that reflects that, not a name that's out and out misleading. Okay. So another principle is with functions, give them names that communicate what they do, their job. Maybe it calculates a value, calculates the max population of cities. Maybe it gets a line from a file. Rather than just calling it, for example, line reader. You could call it read line, for example. That would be more active. Line reader really doesn't communicate, well, okay, so it's a reader. What am I doing? Getting information about its status. Similarly, you don't want to name something check octal, but is octal. Is implying it is returning. Again, what's its job in life? It's to return a Boolean that indicates is it true or false. In this case, is it octal or not? Whereas check octal, it's not clear. Maybe its job is to see whether it's octal and throw an exception or bomb out of the program or what have you if it's not the case, or fix it up. Okay, some other pointers here. So for global variables, some people use initial capital letters to indicate globals. Other people use G underbar to indicate a global variable. So when you look at a variable, you know, oh, this is a global, and therefore I can't find its definition right in this module, for example. This .c file. Maybe it lives in some other .c file. Maybe you want to use virtually always all capital letters for constants. We saw that. And when combining words and names, concatenate and capitalize using camel case, in other words, or use different programs will have different conventions as to which of these two. If you just put it all in lowercase or all in uppercase, by default, it's confusing. The most important thing here is to be consistent. Stick with the conventions of those people you're dealing with. So, because the job of this, in large part, is to communicate. Communicate to others as much to communicate to yourself. Okay. So in C++, C and C++, there's some naming conventions. You folks, how many people here are in 270 right now? So you folks, if I said a class, you have a sense of what it is? It's kind of like a mold out of which it kind of defines, so if we have a person class that defines personhood, so we can create particular instances, this person, that person, Joe, Mary, Sam, and those, just like a mold out of which we can make, cast particular things, or a cookie cutter out of which we can stamp particular cookies. This is a mold. So classes within in C and C++, and in Java and other languages as well, are by tradition in uppercase. First, I should say that first letter is uppercase. I shouldn't say uppercase, it should say the first letter is in uppercase. And if you don't do that, you're going to throw a lot of people off. A lot of people are going to be quite confused. Methods, functions, and fields. First letter lowercase, typically. Action method should be named with raw. Process proceeds. Check file consistency. Send file to home office, what have you. Is for booleans we've talked about. There's an important distinction that we will often make between two types of functions, or two types of methods when you're dealing in an object-oriented, so-called object-oriented context. One is the type of method that does something. It performs a job, and typically as part of that it modifies something. It writes a disk, it pushes something out of the network, it updates something on your screen. It actually changes something. And we call that a command. This is just a convention. So we talk about commands. Functions as commands. Say, do something. And it says, yes, ma'am, or yes, sir, and it goes out and does it. Okay? So we might have perform, the name is perform X, or write file, or something like that. So it actually changes something. The other is called a query, okay? And this actually returns a value. It doesn't change anything. It just computes something and returns it. So is optional is the case of a query. But sometimes you may have, get wealthiest cities, or find, so compute delinquent receipts, and it will give you back the delinquent receipts. So queries, often we may have get in front of them, so get delinquent receipts might be, or we might have some other sort of counting phrase. Then we might have converters that say like to this, convert this to that. Okay. So within this context, constants again all uppercase. Sometimes you use, very often if you need to have different words in a constant, you can separate them with an underbar rather than using camel case. It's all uppercase. You don't have that option. And local variables are like fields, but they can be short often. And if you have an interface, which is maybe a more advanced thing you won't see in 270, but it's an important concept, kind of like a class, but it doesn't define an implementation. It defines a contract. They start with I, capital I. Okay? So these are some conventions that are often used. So this is an illustration. Some class name, a type name. How do you create a new type we know how to create classes, you see in 270. How do you create a type in C? Just C by itself. How do you create a new type? You can do so with struct, but have you folks seen another mechanism that goes beyond struct? So you don't have to everywhere say struct point or struct coordinate or something like that. What's the other thing you could do? You could use I guess you folks haven't seen it. You gotta if you're gonna be in C, you should really learn this. It's called a type def. See? Okay. Type def, struct, such and such. Maybe you don't even give it a name here, so you define this, and you call it, coord or something like that. So this is a coordinate. So you type that. So that would be in first letter capitalized and so on. Now here they have uppercase for methods. Typically they're lowercase in many programs. You'll notice here global variables using G in front, and member variables within a class using M. Macros are by convention, in most cases uppercase, in many conventions used by programs. And sometimes if you have several types of things, like several types of colors, you may have color underbar red. So that's one convention that's useful for you folks to know. And the point is to have some consistency in how you do this. Now, using names, and we're probably not going to have time to go through this in detail today, but when we have a name provides us a mechanism for characterizing information that may be useful to someone when manipulating it. One thing is the scope. So is it a global? Is it a member? In other words, does it belong to a class? Is it a local variable? These are useful things. You can distinguish the scope. You can distinguish, is this, we talked about a type or a method or a type or a function, etc. What types of things it refers to. And you may say, like, you may want to have a qualifier on it. This is the max income, or it's the max receipt, or the max allowance claimed, or what have you. You can decode whether it's an index, we saw that with I before, or whether it counts something, in which case you might denote it with CT in front of things. So CT cities might denote count of cities, okay? That would be one way, another way would be write out count cities. Okay? You might have dimensions, we saw that earlier, units, miles per gallon, or MPH, what have you. And some people, and you'll find this very widely used, particularly in the Microsoft-related software, they'll actually encode information about what sort of information is stored in the variable in terms of the type. Is it a pointer? Is it an array? Is this referring to a double, referring to a character? There's this whole use of an encoding system known as Hungarian. And Hungarian, for example, will indicate pointers with a P in front. So this would be used for pointers, and then you'd have the name. It would indicate a string, a zero-terminated string with SZ. It will indicate a pointer to a function, which you folks haven't seen, probably by PFN. It would indicate an array, say by ARR, etc. And so you use that as a prefix to your name, and you know what sort of thing it is that I'm dealing with. That's one convention you'll see used in some professional software development. If you use Microsoft's APIs, you'll see quite a lot of use of this. Okay, so we're going to be finishing up now for the day. Many of you are going on to lab. Just want to remind you of some of the benefits coming out of this. Greater transparency, easier debugging, faster searching for variables, simpler integration, and you can avoid a lot of mistakes. You can avoid things like you're actually assigned to a global when you think you're assigning to a local variable. So you override something that goes all the way to the structure. You mistake the type associated with the variable and you get a compiler error. You need to recheck the value of a constant. In other words, there's a value that hasn't changed, but you end up needlessly rechecking it later in case you don't know that it's a constant value. And then mistakes where you do something like you assign something measured in kilometers per hour to something that's measured in miles per hour. Okay? So those are just some pointers with names. We're going to be going on next time to talk about a variety of ways to improve code in terms of expressions and in terms of the statements you put in terms of managing side effects, etc. Okay, so you folks should be going on to finish up your lab today. Make sure you turn it in by midnight tonight, by 11:55. Thanks. Thanks.